Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about how to solve systems of equations by substitution. So we've already talked about how to solve systems of equations by graphing. Now we're going to talk about an alternative method. I think we're going to do about 3 examples today, and they're going to get progressively harder. So let's take a look at the one on the left. Now you could certainly try to go ahead and solve this by graphing, but it may not be the quickest method, right? Maybe you don't have graph paper, maybe you don't want to have to sketch everything out, and you're probably going to see that substitution is a little bit more efficient. So let's take a look at this one. Now, if I just look at the first equation, right, and you're being asked to solve this system, but if you just look at the first one, you got to think, well, why can't I just solve the first one on its own and then solve the second one on its own? Think about that question. Why couldn't I just solve both of these equations individually? Well, the answer is, right, they have 2 variables. So I can solve an equation with one variable, like 4x minus 5 is equal to 15, because I can just get the x by itself. But if I have an equation with 2 variables, well, even if I get one of the variables by itself, I haven't found the value of what those variables should be, right? Because there's still this other variable in the equation. So we actually have to use both equations together to solve the entire system. So if we look at the first equation, I have y equals 2x minus 1. Well, if I know that y is equal to 2x minus 1, and I have a y in my second equation, I can make a substitution. I can create a third equation with only x's, which means I'll be able to solve. So my third equation, my new equation, if I replace the y with 2x minus 1, I get 2x minus 1 is equal to 5x minus 7, right? Because I know that these two quantities, y and 2x minus 1, have equal value. Right? These two quantities right here are equal, so it doesn't matter if I replace one with the other, the equation will not change. Right? And you can think of a sports analogy. If you're playing a soccer game and you're making a substitution, generally you're trying to put someone on the field who's just about as good as the person that's on the field, right? So that your team kind of stays the same. You don't necessarily, want your team to become a lot worse when you make that substitution. You still want them to perform well. So when you're substituting two things in a sports game, a lot of times you're trying to substitute two players who are equal in value or they're equal in skill for their position. In equations, when you make a substitution, it has to be two things that are equal, right? It can't be two things that are almost equal. In math, two things are equal or they're not equal. There's no in between. But just throwing you the sports analogy because it's the idea of replacing one thing with another. And in math, those things have to have the same value. So once I create my third equation, I think it's pretty easy to see that, well, I can just solve this for x, right? I can get x by itself here. So I'll subtract 2x from both sides. That'll give me negative 1 is equal to 3x minus 7. I'll add 7 to both sides. Make sure I add it. That'll give me 6 is equal to 3x. And I'll divide both sides by 3. And that will give me x is equal to 2. So I know that my x value has to be equal to 2. But in this system of equations, we have 2 values, right? We have an x and a y. So I have to go back and find out what my y value should be if x is equal to 2. And here we're going to make another substitution. I'm going to take this x value of 2. And let's just choose my first equation. So I have y equals 2x minus 1. Well, I already know that x has to be equal to 2. So I can replace x with 2. And once I simplify, I find that y is equal to 3. So the numbers that work for this system of equations, the numbers that will make both equations true, are 2 for x and 3 for y. And if you want to, it's not necessary, but you could write this as a point, right? 2, 3. You can either show them in boxes like I have here, what x is equal to and what y is equal to, or you could write it as an ordered pair like I did in orange. All of those would be acceptable answers. Now it seems like maybe you think, well, I know that it works for the top equation, right? I know that 2 and 3 work for the top equation, but what about for the bottom? Because we haven't worked with that as much in this example. Well, you could also test it, right? We did work with it right here when we made that initial substitution, but let's also make sure that the numbers work. Both numbers work for the bottom as well. We're not doing this equation. So I have y is equal to 5x minus 7. Well, I know that y is 3 and x is 2. 5 times 2 is 10. 10 minus 7 is equal to 3. So you can see that those numbers also work for the bottom equation as well. Now, when you're doing substitution, you have a lot of choices. There's many different ways you can use the substitution method, especially when both equations are already solved for y. You can always pause the video and make sure you have written down what you need, but I'm going to erase just to show you another method. I guess I could just erase everything at once. That would have been easier. So let's think about this. Instead of substituting in to the second equation, I could have actually substituted into the first, because I know that y is also equal to 5x minus 7. So I could have started with my first equation, y equals 2x minus 1, and I just could have substituted in the 5x minus 7 for y. And you'll notice that this is the same equation as what we came up with before. The sides are just switched, right? The left and the right side have been switched. So when you solve this, you're still going to get the same thing for x, right? Subtract 2x from both sides. I'll do this all in one step. And we're going to add 7 to both sides as well. So these simplify, and I'm left with 3x is equal to 6. Divide by 3, and I get x is equal to 2. So again, didn't matter which equation you substituted in for, you got the same answer. And then I could have actually taken this number for x and substituted into our second equation. Right? And the first time I did this, I substituted into the first, but it's up to you. Right? To figure out the y, you can use either equation. You don't have to use both, you just need to choose one, because you're going to get the same y value either way. Okay, let's look at a slightly more difficult example. Again, we'll look at the one on the left here. So take 30 seconds, think about what's different about this system of equations than the one up above. So pause the video, take 30 seconds to think. Well, the difference is, right, only one of the equations has the y by itself, the bottom one. So while there are multiple ways of solving this system, there's one way that's the easiest, the most efficient, the one that will take the least amount of steps. And to do that, we need to start with our second one and realize that y is already equal to 7x plus 3. So we can take that value and replace the y in the first equation with that quantity or value. So let's start with my first equation, 3x plus 2y is equal to 6. And instead of y, I'm going to replace y with 7x plus 3. Remember, because our second equation tells us that y is equal to 7x plus 3. So I can replace the y in my first equation with that quantity. Now I have an equation with just x's in it, and I should be able to solve. And again, I'd encourage you to pause the video and try to solve it on your own. Good practice solving a one-variable equation. First thing I'm going to do is distribute. So I get 3x plus 14x plus 6 equals 6. Combine some like terms, 17x plus 6 equals 6. Whoops. Subtract 6 from both sides. I get 17x is equal to 0. And if I divide by 17, I actually get x is equal to 0, which is fine. That is a number that x can equal. Now that I have solved for one of the variables, now I need to figure out what the y value is. Well, again, this is up to you. You can choose to substitute this into the first equation to figure out y, or you can choose to substitute it into the second equation to figure out y. I'm going to choose the second one because y is already by itself. It's going to make it a little bit easier for us. So I have y is equal to 7x plus 3, but I already have solved for x. I know that x is 0. So replace the x, whoops, not equals, plus 3. Replace the x with 0. 7 times 0 is 0. 0 plus 3 is 3. So x is equal to 0, y is equal to 3. If you want to write that as an ordered pair, well, we just would have 0, 3. So any way of writing it is correct. You can either just say x is equal to 0, y is equal to 3, or you can write it as an ordered pair at the end. So when only one of your equations is solved for a variable, you're going to choose that one to make your substitution, all right? Rather than trying to get y by itself in this equation and then substitute, choose the easy method, right? Y is already solved. Y is already by itself in the second equation, so you can just take what's on the right side and substitute it into the first equation. Let's keep going. Let's look at one more example. Told you they're progressively getting tougher. So again, we'll stick with the left-hand side. Again, pause the video. What do you notice about this system of equations right here? Over here, that is different from the previous two. Well, neither equation is solved for a variable, right? The x's and the y's are on the same side. So when this is the case, you have an option. You can either solve the first equation for one of the variables, or you can solve the second equation for one of the variables. Now, let me show you both equations, how we could solve, and then you'll kind of make the decision about what's easier. So let's start with x minus 3y is equal to 2. Now, there's nothing that says I have to get the y by itself, right? You can actually get the x by itself and do the substitution method as well. So that's what I'm going to do here. I'm going to add 3y to both sides. And that's going to give me x is equal to 2 plus 3y. Now notice that with just one step, I have already solved the equation for x. So I could immediately do my substitution. I could take this quantity right here, because I know that that is equal to x, and I could jump to my other equation and replace the x with 2 plus 3y. So let's do that. I have negative 3x plus 5y is equal to 2. I'm going to replace the x with 2 plus 3y, and then write the rest of the equation the same. Now you're going to go ahead and solve for y. So in this problem, we're solving for y first, and then we'll solve for x. But again, it doesn't matter. We can solve for whatever variable we want first. So I'm going to distribute. It's going to give me negative 6 minus 9y plus 5y equals 2. Let's combine my two like terms. So negative 9y plus 5y will give me negative 4y. Let's add 6 to both sides. Negative 4y is equal to 8. I don't know why it keeps disappearing on me. Let's come up here. Negative 4y is equal to 8. And I will divide both sides by negative 4. So I get y is equal to negative 2. So we've solved for one variable. Y is equal to negative 2. Now we can use this value, right? I can take this y is equal to negative 2 and I can substitute it into my first equation, or I can substitute it into my second to figure out what x is. Completely up to you. I'm going to substitute into my first. So let me come over here. Again, we're not doing this problem. So I have x minus 3y is equal to 2. Well, I know that y is equal to negative 2. Negative 3 times negative 2 is positive 6. Subtract 6 from both sides. And I get x is equal to negative 4. So y is equal to negative 2. X is equal to negative 4. And we have solved this system of equations. Again, if you want to write it as an ordered pair, negative 2 comma negative 4. Now I did say that there were multiple ways of doing this, right? I said you had some choices. I think I did it the easy way first, right? So it may look like a lot of steps, but I think this was probably the shortest way of doing this. Let me show you another way, just to show you that there are more ways, but that some can get a bit more complicated. All right, so pause the video, make sure you have written down what you need, and then we're going to start this again. So remember I said that you could use either equation and you can solve for any variable first. Right? So we just chose to get the x by itself first using the first equation. Maybe let's use the second equation though. So let me use this equation. And maybe let's try to get the y by itself first. So we'll add 3x to both sides. So I'll get 5y is equal to 2 plus 3x, or you could do 3x plus 2, either way. And I got to divide everything by 5. So I'm going to get y is equal to 2/5 plus 3/5 x. So we've solved for y, and we could take this quantity right here and substitute it back into the first equation. So we used the second equation to solve for y, then we need to substitute back into the other one, the first equation. I guess let's take a little tangent here. It is important to realize that whatever equation you get the variable by itself in, when you make your substitution, you have to substitute it into the other equation. What you could not do is substitute this back into this equation for y. That is not going to work because you're using the same equation twice, right? You would be trying to solve the system using only a single equation. So make sure that when you substitute the expression in for whatever variable you solve for, you substitute it into the other equation. Well, let's think about what happens when I do this. So I have x minus 3y is equal to 2. I need to substitute in for y. So I get x minus 3, and then in parentheses I have 2/5 plus 3/5 x equals 2. Well, you're probably going to notice that now you've got to work with a bunch of fractions, right? When you distribute, you're going to have fractions. You might have to add fractions together. And while not impossible, right? It's just more difficult because we've got to think about all of our fraction rules again. So solving it this way would get you the same value of x, right? We did say x was equal to -4. So if we solve this, we should get that x is equal to -4. But look at how much extra work we're going to have to do, right? So I get x minus 6/5 minus 9/5 x equals 2. Now when I combine my like terms, I've actually got to figure out how to add, a fraction to a whole number. It turns out that this is going to be equal to -4/5 x minus 6/5 is equal to 2. When I add my 6/5 to both sides, let's bring this up here, I get -4/5 x is equal to 16/5. And then if I divide, if I divide both sides by -4/5, I do end up getting -4. But again, I'm doing a lot of that work in my head because I've worked with fractions for many years, right? But you guys, you're still kind of, making sure you've solidified all of those fraction rules. They take you longer than working with integers. So make it easier on yourself. When you can recognize, let's get rid of this and just focus on these two equations here. Things to look for when you're trying to figure out what's going to be the easiest method. Look for an equation where the coefficient of a variable is equal to 1 and solve for that variable, right? The x here has a coefficient of 1, so you want to get the x by itself in that equation. That will ensure that there are not going to be fractions for you to work with, unless there were already fractions in the equation, but here they're not. So if you can find the variable that has a coefficient of 1, you want to solve for that variable. That's going to be the easiest path to getting to the solution. Okay, I think we have gone long enough for this video, but hopefully those 3 examples have provided you with the tools necessary to complete the rest of the problems. As always, enjoy your day, and I will see you next time.